So that was not intentional, but I kind of making my point for me, I guess. So basically the idea was, to explain, or to be nice a bit, like, how to meaningfully contribute to, well, Python, we had PyCon, but really like open source project without being very good at programming or computers or slide system. So my name is David, Cournapeau, but David is fine. It's my first time being in Thailand, I'm really excited. And if you're interested, you can follow me on Twitter and my GitHub account, etc. So you may have guessed already I'm French, that's why I have this stereo accent. But actually I live in Japan. I did my PhD in Japan, and I've been back in Japan in Tokyo for 2 years now, working for a deep learning company, but I will not talk about that today. And I don't do so much anymore, but I used to do a lot of open source, a lot of Python and machine learning. And so I've been involved with like NumPy since before the 1.0 day. I did a lot of SciPy, and I studied scikit-learn. Sounds really impressive, right? Oh, this guy did everything. And well, actually, not really. I'm proud of what I accomplished in the project, of course, but again, I don't think I didn't do this because I was particularly smart or a genius, or again because I knew about computers, because again I cannot make the keynote work. So really, like if I look back into like my last 15 years of involvement in open source, I think really what made it work was I got lucky. So the luck was really I got involved a bit by accident with NumPy before the 1.0 days. So not a lot of people were using NumPy at that time, and so just by being there. And having like, I was a PhD student, so I had a lot of time on my hands. And so, I had time, And so like luck and right place kind of thing, right time, and serendipity as well. And so, like one of the first things, that really, I think is important to start something is like to start simple. That sounds a bit trite and obvious, but I want to explain a bit concretely how that worked for me, and how I think, I've observed that myself as a maintainer for NumPy, that, a lot of people when they start, they really, the ones who stay on the project are people who like start something simple, because when you start something simple, you're more likely to actually finish it. And when you finish it, you're most likely to be more motivated by doing it and by continuing it. And so actually, when I started contributing to Python, it had actually nothing to do with NumPy and scikit-learn and all of that. Actually, the first thing I did was sconce, or contribute to. So sconce is, I don't know if people know about it. At some point, it was a bit popular. I haven't followed recently if it's still used a lot. But basically, it's a kind of a make replacement. So the idea is, it's a build tool in Python, and you can build software. And at that time, I was a research engineer in Japan, and I wanted to build some C software for like embedded Linux software, and for people who know that are old enough, I was dealing with auto tools and all this stuff, and it's not very pleasant. And so instead, I was using this tool sconce, and that was my first contact with Python. And as it happened, sconce was actually really important for me for my involvement in NumPy. But again, start simple. I just use the tool. I contribute some very minor patches, and just allow me to learn like the basics of Python and to build some software for what I need to do for my day-to-day job. So that was in 2004, 2005, something like that. So then in 2006, I got a scholarship to start my PhD at Kyoto University on like speech recognition. And at that time, again, NumPy, all these things were not like super, it was not NumPy 1.0 yet. It was not super stable. You had like NumArray, numeric, especially for me, again, I sucked at programming. I didn't understand those things. They sound very complicated. And I was more like a MATLAB guy. So I don't know if many people know MATLAB here, but if you're coming from electric engineering, which was my specialty, it was a very commonly used tool. So it's not an open source software at all, but it's like kind of an interpreter that allows you to like a numerical computation. It's really good for signal processing. Its documentation is really good, and the UI is pretty easy to use as well. But in 2006, when I studied my PhD, I wanted to do something a bit different, partially because MATLAB is great when you want to do numerical computation, but it's not that great as soon as you want to do something that is not numerical computation. And for example, in my case, when you do speech recognition, like sometimes you need to do like text parsing, so you need to deal with text, with strings, these kind of things. and MATLAB was not great for that. And so I was, okay, I'm doing a PhD, you know, I'm starting 2006, so why not learning something new? So I started to go into this NumPy thing. And so one of the things that you need to do when you do speech processing or speech recognition, you deal a lot with, you know, speech data. And one of the things you deal with is spectrogram. So I won't talk much about the details here, but the idea of a spectrogram is just, you know, it's basically the frequency in time and how it evolves in time. And, you know, here you can see, you know, if you know a bit about speech, like the first, so it's time, right? The first like 100 milliseconds, it's like one of a vowel. That's why you have those very clear line, yellow, red. And so, it's very useful to understand like the sounds, and like when you want to do speech recognition, you often start from a time frequency perspective. And so, like one of the first things I wanted to do in NumPy was to basically, you know, use spectrogram. And there was already a function to do that, but it was really, really slow. Like it was like 10 to 50 times slower than MATLAB. And so, you know, before, when I was doing a spectrogram in MATLAB, it would take, you know, I wouldn't notice, it would be fast enough. But if I do it in NumPy with MATLAB, it would take, you know, 5 seconds, 6 seconds. And it was always annoying because you wanted to do a lot of them all the time. You didn't really know what you were looking for at the beginning. So it was kind of a bit annoying. And so that's a faithful email. Like me in 2006, you know, thanks to Google, I managed to find this email back. And so this is here and asking some questions. And, you know, I said, okay, NumPy, MATLAB is great, but it's a bit slow, and it was a bit difficult for me to use in an iterative manner. And so basically I asked some people, you know, what can I do, you know, to improve this? Like maybe I was not using it correctly, or maybe there's a bug, like who knows, right? So, you know, going back to the studying simple lesson, like at the beginning, you know, I didn't intend to be involved in NumPy or MATLAB or this software at all. I just wanted to get on with my work. I just wanted to do my spectrogram. You know, I was pretty focused on getting that work. But you know, what happened is, because I looked a bit into this issue, I got a bit more involved, and you know, it was not just for spectrogram, but basically I became really involved in NumPy. And at some point, you know, I was one of the main committers to NumPy, and I did a lot of code contribution, and it took a lot of my time. I easily took half of my time doing my PhD. Something else, I started a bit around the same time, 1 year later, that maybe is a bit small, but so in 2007, 2008, so Google already started to do something called like a Google Sum of Code. I think this is still going at the moment. And at that time, it was still fairly small. And so the idea is fairly simple. Google wanted to give some money for open source project, but it had to be mentored by somebody already working on the project. And myself, you know, at that time, NumPy, SciPy, all of this still pretty new, and I wanted to do some machine learning, because when you do speech recognition, you use something called machine learning, AI, deep learning was not really a thing yet. It's kind of the same set of ideas. And like I had a few scripts that I built for myself. And so, you know, after having talked to some people in the SciPy community, they suggested, okay, why don't you create your own package, and you can do that with, you know, through the Google Sum of Code. And so the person who helped me at that time was Jared Millman. He was working in the IT department of Berkeley University at that time, and he was in contact a lot with some people. At the same time, you had people like Fernando Perez, the creator of the IPython project that became Jupyter. And you know, you had a bunch of people at Berkeley University at that time, and so he really helped me like starting this project. And in the Google Sum of Code, you have this official mentor-student kind of thing. So that's another thing I really recommend for people who are like interested in like starting, contributing to a project, open source in general, but don't really know how to do, is to find a mentor, to find somebody who's willing to spend time with you to basically go through. No, it's the same like in every kind of social endeavor, you know, because we're human, we are like social animals, right? And there are always a lot of codes when you go somewhere. Like, for example, you know, some of us, you know, for me, it's the first time coming here in Thailand. I know there are a lot of things I don't quite understand. I know when I interact with people, I'm sure I kind of appear clumsy. I don't really know exactly how to do. There's a lot of informal kind of things. And, you know, especially when you're young, you know, you're afraid to make mistakes. And instead, like if you have a mentor, he can help you for all of these informal kind of things. So yeah, like, again, I wanted to do my spectrogram, but, I ended up, doing this Pi machine things that became scikit-learn, and I contributed to a lot of NumPy, and again, I think I spent easily half of my time doing my PhD doing this kind of contribution to open source project. But again, I'm not here to congratulate myself, and it's not false modesty either, but the thing is, I didn't build a lot of feature in NumPy. I did I forgot the number, more than 1,000 commits, who cares? I didn't build a lot of new feature, I just did what I was interested in, which was understanding of some things work in NumPy. As I all go back to the initial thing I was doing for the spectrogram, I won't bore you with the details, but basically the reason why the spectrogram was slow when you do NumPy and MATLAB is simply because the clip function, so that clips an array that basically say if the value of an array is below a certain value or above a certain value, you just clip at those values, was really, really slow, much slower than it had to be. And I got involved in the C code because it was done in the C part of NumPy, and I just did more of that because I became interested in that. So NumPy, I contributed a lot of code, a lot of commits, but actually I didn't contribute a lot of features. Scikit-learn, it's the same. Really the main thing, I joke, but it's true. The main thing I contribute to the project is the name, and that's why I bootstrap the project. But really the main people who made it successful, you have a lot of people, of course, because it's a huge project now. But really what happened is after I graduated, a friend of mine, Gaël Varocco, who was a researcher in France, he had a master's student, Fabien Peregrosa, and they worked together. Basically, Fabien got, Gaël got, what's the name in English? Some money for 1 year for Fabien to work during his master on an open source project. And that's kind of how scikit-learn became really a thing. And then one of the things that is really a key to scikit-learn success is the documentation. That is definitely not thanks to me, but that was Gaël and Fabien really from the start, making sure that every feature is well documented with a lot of examples, and a lot of tested data, so people have an idea on how to use the algorithm, and having some examples to start from. So really that's kind of the second idea I want to convey, is contributing is different from building new features, which is even different from coding. And it's even more and more important that people understand that, especially for large open source software projects, code is only part of what makes a project work, right? I mentioned before documentation, which is one that comes often, but also helping other people to start, right? You may know very well about the project, maybe you don't have time or you don't want to contribute to new features, but you can easily help other people to use the software, you can advertise the software, a lot of those things contribute to helping the project and doesn't require you from being, especially, technically good, so to speak, at programming. So really, contributing as a beginner, how does that work? I think there are many ways you can do it. I use my own example, which again I think is fairly common. Is you don't necessarily know how to do something, but you want to do something and you really care about it. And that's the whole scratching your itch. That kind of became a cliche a bit, but I think it's still true that if you want to contribute, a good starting point to contribute to a project is really through solving something you really care about. But something else that works really well actually is if you write beginner's note. So one of the things is if you're a beginner, and I mean beginner in a fairly large sense, it could be your beginner is a project, or it can be your beginner at programming. But one of the things you have as a beginner that more experienced people don't have is by definition you're a beginner. And you may think that, okay, it's essentially a burden because you don't know how to do things, but actually that's also a comparative advantage because you can offer a fresh perspective to project. And one of the ways that it can be very useful to offer a fresh perspective is writing beginner notes. So it could be on the official documentation, on your blog, on however you want, whatever is the most convenient for you. But what I mean by that really is, okay, if I'm a beginner, I don't know how to do something, so I spend a lot of time doing it because maybe the documentation was not very good, or maybe I wanted to do something a bit different from what is written in the tutorial. And that's the kind of thing you can contribute yourself. Just write down what you did, and most likely you can help somebody in the same situation as you. Because there's something that is very easy to make as a mistake, especially as a beginner, is you don't see, well, you only believe what you see, so to speak. Like, even, internet, you have a lot of information, etc. But actually, you have a lot of things that people don't write about, right? For like everything that is written about, you have maybe 100 people who don't write anything about. Like a lot of people, they have an issue, but what do? They just stop, right? It's actually pretty common. And myself, half of the time, if I have an issue, okay, I move on and I try to do something else because it's not so important. So instead, don't be too, like, oh, if nobody is right about it, maybe it's not interesting, or maybe it's too obvious. Most likely not, because if it's difficult for you, you can bet that it will be difficult for a lot of other people. And again, that's something that you have better perspective as a beginner, because, like when you're more experienced, almost by definition, you don't really see the problem you're having anymore. So something else that is a bit close to it, but not exactly the same, is document the feature you know about. So that is a bit related to a different idea, is when you start on a project, or when you start generally like contributing to open source, is you come with your own background, and most likely you have some domain expertise. But the domain expertise doesn't have to be technical. That's something I cannot stress enough. Like, it can be technical, of course. In my case, it was kind of technical. I was doing a PhD in speech processing. I knew quite a bit about speech processing, and I wanted to use NumPy and MATLAB for that. And not many people were using NumPy MATLAB for that use case. But it could also be something else. Sometimes, your expertise could actually be, maybe you haven't studied software engineering, but you study, for example, how to write well, and that's something I'm not a native English speaker, but a lot of in the liberal arts schools, you can basically you supposedly learn about how to write well. Engineers generally are not that great at writing very well. We try to be very dry, very technical, because we think it may look as very smart, but actually it's mostly bad writing. And it's not so nice actually to understand what the feature is about. And so if you know how to write, and you know how to write, how to write like stories, and you know how to write well-structured text, it can actually really help to write documentation. Because something that happens a lot is when you have an open source project, you have the basic documentation is often there, like the documentation of the functionality, or the documentation of what is this argument doing for this function. An open source project, it depends a bit on the quality of the documentation, but that people generally do. What is often lacking is the documentation is a more prose-like documentation to explain what is a project about, right? And scikit-learn is a good example for that, because when you go on the website, even if you don't know anything about machine learning, it kind of gets you there in the sense that it tells you, okay, what is scikit-learn about? What can you use it for? What can you cannot use it for? And writing this kind of documentation, well, it takes a lot of time and takes a lot of skills, and you can be good at it without being good at software engineering. So when I say document feature you know about, it's actually a bit more general than that. It's just, if you have domain expertise, you can write the documentation if the documentation is not very good. Or also you can, if you're, for example, good at writing, you can use that skill to contribute to documentation. So yeah, that's something I already mentioned a bit before, but using your knowledge as a domain expert. And again, expertise doesn't have to be technical. So writing well, in a way, is a domain expertise, right? And that's something you can rely on. Something else that can be useful is if well, no, it's a technical expertise, but if you know how to write a website, you're good at UX, you're good at UI, you can have something to contribute to, sometimes again, some of especially scientific kind of open source project, they don't know how to write a website that had a good standings and make it easy to read, or sometimes it can be difficult to read for people who don't have good vision, accessibility kind of perspective, that's something as well that there is always a need for this, and some people don't think about it at first, but that's something that can be very important and useful to contribute for documentation. And the last point I want to stress, and I already mentioned that a bit at the beginning, but again, when you're a beginner, it's easy to think when you look at the, the information on the internet and everywhere that, oh wow, like, so people that are so good at programming, and myself, I realized, at first, like, it was a bit intimidating because, like when I was working on NumPy, there was like the creator of NumPy, Travis Oliphant, and like basically he rebuilt the NumPy, so to speak, from like older project, Numeric, in 6 months, and I was like, oh, like how can you do that? Like it was really impressive for me. And but the thing is, like most people, they don't start good, right? Like they themselves were a beginner, they had to start somewhere, and be mindful, basically, that what you see on people is the state they are in now, right? Like it's not like it's not like you don't see how they were a beginner 10 or 15 years ago. You see how they are now, like after all the experience and all they managed to learn. And really, again, it's a bit like the point I was making before, like, for one message you see on the internet, you have 100 people who don't say anything or don't write anything. And really, like, just a willingness to contribute actually put you ahead already. If you're willing to spend a bit of time, if you're willing to, just look at something that you think you can improve and just do something, spend 1 hour or 2 hours on it, it already puts you ahead. As software engineering or programming, you can just do, just having some time and, not, instead of watching Netflix or whatever, like instead spending a bit of time to contribute to an existing project is already, something, again, that puts you ahead and that the project, a lot of more project can use for, because really the main thing that people are lacking when they contribute to a project is time. So, yeah, I hope that it was a bit of a short talk. Like we had some technical issues at the beginning. I had to shorten it a bit. But if there's one idea, I hope you can, keep in your mind, especially the younger among yourself. Sorry, is that you all have something to contribute. You all have something. You can teach others. There is always something you know more than a lot of other people on this project and can help you contributing. And I hope for some of you, it will at least motivate you to maybe you're a bit afraid of making the first step to contribute. And I hope for some of you, it convinces you that actually you have everything already you need to contribute. You just need to put a bit ahead. And so if you have some questions and if you want to talk to me more about you want to start contributing on a personal project, we don't know how, I will be here during the World Conference. I will be more than happy to help you. Thank you.